New study shows updated map of Earth's tectonic plates. By David Bresson. Based on a series of models considering how the continents were assembled over time, a team of researchers at the University of Adelaide created an updated map of Earth's tectonic plates. The map will help provide a better understanding of natural hazards like earthquakes and volcanoes occurring along plate boundaries. We looked at the current knowledge of the configuration of plate boundary zones in the past construction of the continental crust, said Dr. Derek Hasterach, Department of Earth Sciences, who led the team that produced the models. The cratons of our modern continents, the continental cores with the oldest and thickest crust, formed more than 3.2 billion years ago. Over time, more and more crustal fragments formed, pushed together by convection currents in Earth's mantle, forming the first supercontinent called Valbara. These collisions were accompanied by mountain building processes along the boundaries of the tectonic plates. Eventually, Valbara broke apart, forming a subset of smaller continents. In the last 3 billion years, a number of supercontinents formed and broke apart again, with the most recent being Pangaea, a supercontinent existing from 335 to 65 million years ago. Today, Earth's crust consists of 8 large tectonic plates and various microplates. The continents were assembled a few pieces at a time, a bit like a jigsaw, but each time the puzzle was finished it was cut up and reorganized to produce a new picture. Our study helps illuminate the various components so geologists can piece together the previous images, explains Hasterach. To create the map, the team combined 3 geological models: a plate model based on already known plate boundaries, a province model based on the geology of Earth's surface, and an orogeny model with areas deformed by mountain building processes. There are 26 orogenies, the process of mountain formation, that have left an imprint on the present-day architecture of the crust. Many of these, but not all, are related to the formation of supercontinents. Our work allows us to update maps of tectonic plates and the formation of continents that are found in classroom textbooks. These plate models, which have been assembled from topographic models and global seismicity, have not been updated since 2003. The new plate model includes several new microplates, including the Macquarie microplate, which sits south of Tasmania, and the Capricorn microplate that separates the Indian and Australian plates. To further enrich the model, we added more accurate information about the boundaries of deformation zones. Previous models showed these as discrete areas rather than wide zones, said Hasterach. The biggest changes to the plate model have been in western North America, which often has the boundary with the Pacific plate drawn as the San Andreas and Queen Charlotte faults. But the newly delineated boundary is much wider, approximately 1,500 kilometers, than the previously drawn narrow zone. The other large change is in Central Asia. The new model now includes all the deformation zones north of India as the plate bulldozes its way into Eurasia. The team's work provides a more accurate representation of the Earth's structure and has other important practical applications. Our new model for tectonic plates better explains the spatial distribution of 90% of earthquakes and 80% of volcanoes from the past 2 million years, whereas existing models only capture 65% of earthquakes. The plate model can be used to improve models of risks from geohazards. The orogeny model helps understand the geodynamic systems and better model Earth's evolution, and the province model can be used to improve prospecting for minerals, concludes Hasterach. The paper, New Maps of Global Geological Provinces and Tectonic Plates, is published in the journal Earth Science Reviews, 2022. Materials provided by the University of Adelaide.